So, I volunteered to chair the second session and last session for today. We have two more talks before we move on to cocktails, and our first speaker is Cecilia Bustamante of Paris, and she'll be telling us something about the Emile Borel and his notebooks.
Thank you. Okay, thank you. Hello. Buenas tardes. Thank you for coming to my talk. My name is Cecilia Bustamante. I come from Paris, but I come also from Colombia. Okay, I'm going to be talking about a manuscript. I won't be talking about a theory, not of Planck or something else, but about a manuscript, Emile Borel's notebook on thermal radiation theory. The history of this manuscript is as follows. From December 1912 until to March 1913, following discussions on radiation and quanta that took place in Brussels at the Solvay Council, 1911, French physicist Paul Langevin delivered in Paris at the Collège de France a course of lectures entitled Les difficultés de la théorie du rayonnement. During the 1900s, Langevin had given a brief overview on the topic within the courses, which were mainly focused on the electron theory of Hendrik Anton Lorentz. So, the lectures of 1912-1913 were the first that Langevin devoted entirely to new quantum physics. These lectures were followed by French mathematician Emile Borel. He took the notes he wrote down in the notebook. So, emission and reception in my title is related to Langevin's oral speech and Borel's written reception. You can look the manuscript. It's a small, a very small pad that carries on the cover the mention Langevin 1912-1913. It was written by Borel. The title, Les difficultés de la théorie du rayonnement and Collège de France, appear nowhere. This is for me the first announcce of the fact that Borel's notebook has a private character. The mention Borel appears twice in the end papers. On the right page, you see that Borel has put on his signing the address of the École Normale Supérieure, 45 Rue d'Ulmont. The mathematician was, since 1910, its own director, and below he has put on a commentary. It has nothing to do with the lessons, at the sketches of equations and scrolls on the left page. Now, the notebook was part of a small set of papers I discovered a few years ago in Paris in the basement of the Institut Henri Poincaré, so in one of the places where the mathematician worked for several years. It must be remembered that Borel was the founder of the Institute in 1929 and its first director. The documents kept in an old folder had belonged to Borel. They were mostly in very poor condition and consist primarily of drafts related to Borel's work in probability and more generally to his activities in research, teaching, and the organization of academic life in France during the first 2 decades of the century. Also, among the documents were reprints of papers used by Borel in preparing the French version of Paul and Tatiana Ehrenfest's work on the foundation of statistical mechanics. This work was published in 1914 in l'Encyclopédie Mathématique. Borel's paper is entitled Supplement. Now, it is clear that Borel was compelled to follow the teachings on radiation theory by Paul Langevin in the context of his work on probabilities and physical theories, relativity, and statistical mechanics. When the course took place, Borel was 41 years old. He was professor at la Faculté des Sciences de Paris and the under-director of École Normale Supérieure. Langevin was 40 years old. He was professor at the Collège de France. Borel was a major player in mathematics and statistical mechanics in France, and Langevin was a major player in theoretical physics. The two actors were living very important moments of their careers. Also, they were very close friends. Okay, now I'll focus on four main issues. Firstly, I put forward some ideas on Langevin's teaching at the Collège de France. My purpose here is to point out the status of the notebook as a recording of the course. Secondly, I look at the process of note-taking by Borel. I'd like to show you how to read Borel's notes. Then I'll move on to examine the scientific content of the lesson. And finally, I put forward some concluding remarks. Now, I feel my first point. Let me begin by a general observation. I don't know what happened here. Is a problem here? But it is important.
Where's the...
This one. No, because
I don't even know where the file is.
Yes.
Where's I don't see the file.
Hay un problema acá. Acá la puse.
Is it on the USB
¿Qué se me
stick?
hizo? Yes.
Oh, we didn't put it on the...
Espérate, yo tengo... I'm sorry. Okay, yeah. Sorry. Okay. Okay, now, let me begin by a general observation which concerns Langevin's auditors at the Collège de France. It is very well known that they went to Langevin's lectures with a pencil and a notebook and took notes. To write down in the paper was the only opportunity they had to keep a trace of Langevin's courses. Langevin did not like publishing his teaching. He taught at the Collège de France since 1902 until 1939. He never wrote his lectures in order to publish it. In fact, Langevin did not like to publish at all. It is often said that he wrote little, published little research, and did not write books. I should say that Langevin was not an author. In this regard, the contrast between Borel and Langevin is obvious. Borel published systematically all courses he was doing at the faculty. Langevin's persistent refusal to convert his teaching to text have been frequently reported. Lucien Félix, a mathematician and alumni of Langevin at the Sèvres School of Guerre, pointed out that, I say that in French, les cours étaient souvent rédigés par ses auditeurs, jamais publiés par un souci de plus en plus exigeant du maître. I think it is fair to say that Langevin thought that the written document is merely a reflection of the course and never the course itself. We can also assume that he considered, like the students who wrote the course of Ferdinand de Saussure, French grammarian at the beginning of 20th century, that the form of oral instruction is often at odds with that of the book. Many professors in France have this idea that oral speech was not adapted to written text. Maybe we can quote Platon, who was talking about writing and oral speech, and Platon was in some way against writing. Okay, now, wherever our point of view on the topic, these remarks shed light on the fact that there are no written and published versions of the course of radiation theory. A brief summary exists. It was published in 1913 in the Annuaire du Collège de France. At the college, the publication of a course was not part of the obligations of the teacher. However, professors were obliged since 1900 to write a summary of the journal. Otherwise, we know that Langevin was deeply invested in the preparation of his lectures. As his son André said years later, il régnait à la maison une atmosphère tendue que n'osait jamais rompre aucun de nous au moment où Langevin préparait ses cours. However, to my knowledge, there are also no documents related to this kind of activity. In fact, Borel's notebook is the only real document we have to know Langevin's lecture on radiation of 1912-1913. It remains, nevertheless, the possibility of finding other notebooks, such as that of physicist Edmond Boer. Edmond Boer said he took a lot of notes during Langevin's course, which he witnessed at the beginning of the century. He was an auditor to the course on radiation. Moreover, he was working on the subject. His work became the first analysis made in France of Planck's quantum theory. In fact, Langevin's teaching, like the notes of Borel show, is partly rooted in the work of Boer, but doctoral dissertation by Boer itself is partly due to Langevin's courses of 1906, 07, 08. Very close of Langevin, Boer made various comments worth mentioning here. They show us how auditors, and perhaps even Borel, perceived Langevin's teachings. Let me quote Borel. Le premier cours de Langevin auquel j'ai assisté, celui de 1902-1903, m'avait fasciné. Non seulement les idées théoriques avaient été exposées d'une façon lumineuse, mais encore toutes les expériences qui étaient des expériences de recherche visant à mesurer la mobilité des ions étaient faites au cours d'avant nous. In fact, Langevin himself noticed that he always tried to make a lively teaching, and he did not want auditors to forget the experimental research that had founded the theoretical developments. Let me say that Langevin was a theoretist and he was also an experimenter. This point is very interesting for us. Langevin made experimental work on Stefan Boltzmann laws during his lectures on 1900s. However, in 1912-1913, Langevin paid attention once again to this law, but notes by Borel do not refer to any experimental work made during the course. That brings me to the second issue of my presentation, note taking. First of all, I should mention that Borel failed to take notes of the lesson by which Langevin began his course, namely the opening lesson. Opening lesson covered two realities in the Annuaire du Collège de France. On the one hand, is a performance, a vraie performance, that was reserved for the new holder of the chair. It enthroned the professor in his new function. Langevin had assumed this practice in 1908 when he was appointed to the chair of Physique Générale et Expérimentale. On the other hand, an opening lesson is done every year at the beginning of a course of lectures. This time, the professor is enthroned as an expert in a particular topic. So, as may be expected, this opening lesson of the course of lectures on radiation, which took place on 3 December in either room 2 or 3 at the Collège de France, enthroned Langevin as an expert in new quantum physics. On this issue, it should be remembered that Langevin had been an important actor in the Solvay Council devoted to the topic of radiation and quanta. He was among the most active in the discussions. He had been requested to publish the report in French. We can thus imagine that this scientific context inspired the content of Langevin's opening lesson. Okay, now let us look a little bit closer to at the notes themselves. I like to put aside its scientific content. I will come back to that issue later. The pad contains notes of the lessons that Langevin taught between 6 December 1912 and 21 March 1913, 24 lessons. Sometimes notes contain titles, but they are rare. In general, the topic of the lesson is not announced. Here you have a very good examples of notes by Borel. You can see that he dates. In fact, Borel always dates. That is why the notebook allows us, to know the chronology of the course, otherwise unknown. Langevin taught twice a week on Tuesday and Friday. In the morning, in the afternoon, Borel wrote dates, but never the hour. Was Langevin talking during 1 hour or more? We don't know. The Collège de France had no formal role on this point. We know, however, his type of exposition. Langevin registered ideas in perfect order and did calculations by head and by subtle processes. His speech was so well organized that the structure of the lesson was as a train of thought without failure. All this without notes, by a prodigious power of attention. Finally, the most profound ideas, everything was in place. I was quoting Jacques Adamar, mathematician, who was auditor of Langevin. Notes by Borel are so well organized that in some way they reflect this kind of speech, but they are brief and frequently drafted with abbreviations of the words, and so even the equations. Many computational steps are omitted. Here we have a very good example also, because we have here, in the left page, a presentation of Kirchhoff's law, a very general presentation of Kirchhoff's law, but here we see that Borel the equations were always abbreviated. Here, for example, here, and here. I did the calculations, and I say you that Borel didn't write a lot of steps here in the presentation of Kirchhoff's law. The left-right, you have also a demonstration where we see very clearly here that the terms of the equation lacked. But we can reconstruct the demonstration. It is possible because all the terms of what is necessary to do the demonstration is there, but many steps are omitted. Okay. These are right pages of the pad. Borel was used to writing on the right page. On the left page, he wrote only explanations or ideas in order to complete those who are on the right page, like here. So you have there notes on lesson of Brownian movement of the electron, Brownian motion of the electron. Here, that is the note at the notes written by Borel in 17 January. Okay. Here you have some explanations. Was that did by Borel, by Langevin? We don't know. But this, what we have here, complete what we have in the right page. Okay, the last notes are quite different. The last note of the pad are quite different. He wrote wherever and how over the last end papers, almost no matter how. He had no more space for writing. He returned at the beginning of the notebook, where left pages still had free space. Here you have the last note of the teaching, of the course. Here you have the date, okay, and here the notes he took this day. You know, if I think the notes by Borel as a kind of routine. Here we see that there is no more routine, not everything, so he was writing as he could do. Okay? So when he was writing that, this was the last one of the lessons of the course, he comes to the very beginning of the path. That is what we have here. No, okay. Here we have the first lesson of the course was this one, 6 December. Alors, what we have here is very interesting because here we have the notes of 14 March. Here. Here we have the notes which correspond to this part of the lesson. But we understand that now because Borel was writing always in this way. He was writing here, and when he had something to do, something to say, he wrote here. What we have here is very interesting also because it is here only a small introduction of the problem of blood-borne radiation, and there this line is very important because he means by that Langevin was talking about, will be talking about another subject. So here we have a presentation of Hilbert's theory on radiation. Hilbert had published a paper on radiation theory in August 1912. And Langevin was talking about this problem, about Hilbert's paper. So Hilbert was talking about Kirchhoff's law. He was giving a demonstration of Kirchhoff's law. In his demonstration, he was using a theorem, a Straubel's theorem. It's a theorem of optical geometric. And so we have here Straubel, 1903. This is the Straubel theorem used by Hilbert in his work. But here we have the demonstration of the theorem. That is interesting also because in his paper, Hilbert didn't give the demonstration of the theorem, but here we have the beginning of the demonstration of Straubel's theorem. So I wonder, this demonstration was did by Langevin. Borel was a mathematician, but I know now that a young student of the L'École Normale Supérieure published a paper in 1914 on Straubel's theorem, and he said that Langevin was talking about this theorem in his teaching. So I know now that was the demonstration was did by Langevin, not by Borel. But in the other notes, it's very difficult to know if the speech was by Borel or by Langevin. Okay, So now I'd like to turn to my next point. I pay attention to the scientific content of notes by Borel. I'll be showing you that they allow us to subscribe the course on one side in the scientific concerns of Langevin during the 1900s and on the other side in the reports presented to the Survey Council and the discussions that took place there. Identify 5 main topics in Borel's notes. The first one, Langevin, the first 3 lessons of his teaching, where Langevin was focused on David Hilbert's work on Kirchhoff's law, published in August 1912. Borel's notes talk about generalización de la demostración de Hilbert. That it's interesting, yet, because Hilbert gave his demonstration, the demonstration of Kirchhoff's law, and Langevin was proposing at the Collège de France a generalization of the demonstrations of Hilbert. And I know that this generalization is focused on the fact that he was proposing a general version of Straubel's law, Straubel's theorem. Straubel's theorem is a theorem of geometric optics. Okay, so in these lessons, Langevin was paying attention to the work by Hilbert. In 1913, Anton Lawrence published a paper entitled Sur un théorème général de l'optique. So in Straubel's work, Lawrence's study seems too close to what Langevin carried out at the Collège de France, but Langevin published nothing on the subject. Only his auditors benefited from his reflection. Could we establish a connection between the study published by Lawrence and the station proposed by Langevin in the course? The communication was constant between Lawrence and Langevin, so we can imagine that they had the opportunity to speak about it, but the question remains answered. Okay, now I move on to the following notes, the second topic. These notes are very brief, but related to a general theme, thermodynamic laws of radiation. Besides Kirchhoff's law, Langevin was focused on Stefan Boltzmann and Wien's laws, formulated also in the 19th century. According to the summary, Langevin made a detailed study of Stefan Boltzmann's law. Notes clearly show that Langevin's main concern was radiation pressure. He considered the notion within the frame of Lorentz electron theory, as he had done during the 1900s. Borel's notes on Wien's law are also appealing. Langevin focused on Lorentz's demonstration proposed in 1900, but not only. If you look at this page, you can see Loi de Wien. It is the only note, the only time when it occurs in the notebook. In the summary, Langevin talked about the very recent demonstration of Wien's law of radiation. He probably made it during this lesson. I suppose Langevin talked about the demonstration proposed in 1913 by Edgar Buckingham in the state, in Washington. It is the last demonstration made at the time of Wien's law. Okay, the first point on the notes I like to see you is that Langevin moved on to examine the distribution of energy between radiation and free or bound electrons contained in a cavity. While doing that, Langevin focused on several topics. He was talking about la théorie de l'onde d'accélération that he proposed in 1904, or he was talking about also on the issue of Brownian motion of electron in a radiation field. He deepens Lorentz's presentation of the subject to the Conseil Solvay. When the discussions took place, Langevin asked Lorentz if he had published his calculations. Lorentz answered negatively, so Langevin, dissatisfied and motivated, continued the exploration of the problem at the Collège de France. It is worth mentioning here that Langevin obtained an expression for the kinetic, for the electron movement of the kinetic energy of the electron, that it is very, very close to Fokker's work published in 1917. But Langevin never published his work. Okay, another point is the following notes are very brief, but Langevin appears very interesting by the electron theory of Larmor and more precisely by the principle of least action. A very interesting fact is that in 1906, Langevin and Henri Abraham published a work of 2 volumes entitled Ion Electron Corpuscule. It is a collection of works on atomic physics. Among the studies, we find the chapter 6 of Ether and Matter of Larmor. The notes led to this chapter. Langevin was working every time on electron theory. Okay, but in this lesson, much of Langevin's work is concerned with Lorentz proof that the interaction of thermalized matter with electromagnetic radiation led to Rayleigh-Jeans law. Langevin sought to show how Lorentz had applied Gibbs statistical mechanics to an electron gas interacting with cavity radiation. Langevin performed all kinds of calculations to find expressions for magnetic and electric energies. Once again, he deepens what Lorentz presented in 1908 at the Mathematician Congress and 1911 at the Solvay Council. Finally, the last notes show that the first topic of the lesson was the introduction by Planck of quantum of action in 1900. Langevin talked about Planck's first and second theory. I am still analyzing these notes. By now, I know now that Langevin's thoughts are clear. In 1900, Planck obtained by obscure theoretical means a black Borel law that fitted experiments excellently. We read in the notes that, but Planck did not wish to alter the electrodynamics of Maxwell, but a modification in the Hamiltonian differential equations for the vibrations of the oscillator and the corresponding statistical law, the partition of energy, seemed essential to him. So, from Langevin's point of view, Planck's theory lacked much consistency. Langevin focused on another key issues, including Poincaré's work on quanta, but also the notes also mention Ehrenfest, who has preceded Poincaré on this study. And let me mention that the pupil of Langevin, Edmond Boer, was one of the rare physicists to have measured the importance of Ehrenfest's work before the Solvay Council. Boer devoted a chapter of his doctoral dissertation to analyze Ehrenfest's work. Borel did not mention Boer in his notes, but he includes his doctoral work in the long bibliography for the supplement prepared a little time after the course of Langevin for l'Encyclopédie Mathématique. Okay, now let me tell you something. In my presentation of notes by Borel, I have adopted the principle that the mathematician had taken his notes during Langevin's lessons, but we should think that Borel's notes contain also the trace of further discussions on radiation and quanta. Langevin's teaching was not limited to lessons at the time, while the practice of the seminar didn't exist in France. Langevin had gotten used to organizing meetings with the auditors where presentations of topics related to the course were made. Auditors' presentations were followed by discussion, so I should establish a relationship between the meetings and Borel's notes. But at the moment, the issue remains still open. Okay, after all is said, I'd like to put forward some remarks. French quantum physics of the beginning of the 20th century is little visible on the international scene. The historians of the quantum theory, historians of the French physics, have more abandoned her than the study. They generally admit the decline of the French science at the time, the dominance of an experimental tradition inherited from the 19th century, and a mediocre interest for new quantum theories. It remains, however, that we cannot conclude that French physicists totally lost interest in the quantum issue. A notable exception is Paul Langevin, although he hardly published in this domain. Physicist, experiment, and theorist Jan Langevin practiced from his doctoral thesis on the ions a kind of physics who led him naturally to be interested in quanta. His course of the year 1912-1913 in the Collège de France reveals a deep interest in the theoretical problem arising from the work of Max Planck in Germany on thermal radiation. The notes of Borel do not certainly give an image so objective of the context of lessons that would have been made a writing version by Langevin, and furthermore, they are very, very brief. But the interest of Borel's notes cannot be denied. Thanks to the intelligent attention of its writer, they allow us to get a precise idea of how Langevin was working. Also, Borel's notes confirms the correctness of a remark contained in the introduction of the collected works of Langevin and l'avertissement des œuvres. Une partie essentielle de l'œuvre de Paul Langevin en physique se trouve dans ses cours, principalement au Collège de France et dans ses interventions lors de certaines réunions de physiciens, celles du Conseil Solvay particulièrement. The notes of Borel allow us to understand the course in an interactive and a live process, implying the speaker, Langevin, and a member of his public. The interaction is particularly instructive here because both protagonists are important actors of two different disciplines, physics and mathematics. Now, let me say something on Borel's auditor. Borel, note-taker, seems to be the kind of auditor envisaged at the beginning of the 20th century by an author, Paul Chavigny, army medical officer who wrote a small book on brain work and efficiency. He argued that taking notes in a course is a part of essential gestures of the intellectual worker. A good auditor seeks to keep track of oral speech, something that could be evoked at will. The memory is a field of ruins. Notes are something like a personal paper memory. So the last point I wish to make is one of a personal nature. With regard to the notebook of Borel, I'm going against the will of Langevin because I'm preparing the publication of this personal paper memory. So I'd just like to thank you for listening.
Thank you. We started 5 minutes late, so we have 9 minutes for discussion. Arne.
Let me try without the microphone. So very nice talk indeed. I was very surprised when I saw Borel's notebook since some 10 years ago. I was editing Hilbert's lectures on radiation theory, which happened in summer 1912.
Okay.
And it looks very similar. And so this paper from Hilbert from August 1912 was actually a result of his lectures. And so I wonder whether you have consulted this Hilbert edition, which reprinted and commentated the Hilbert lectures and how close they were to Langevin. I was surprised to see that it was also this groupie was busy. And so so my question would be, do you think, well, it's surprising that it's France, it's a physicist, a mathematician, who at roughly the same time giving similar lectures, and that the topic, although new and related to quantum theory, still is very settled. So it's a very similar things, very similar discussions about, say, the geometric problems, and also radiation theory can mean a lot. So Kirchhoff's law can be interpreted in many ways, and they both, at least what I could grasp from you, that they had very similar approach and similar thinking.
Yes, I was really surprised when I find this fact, because I didn't know. I think that historians didn't know this fact, because the only trace we have today of the course is the notebook. But now I think that in some ways normal, because Langevin was very international. And Langevin was, every time he was in touch with German physicists, and furthermore, Langevin in his course was addressing to mathematicians, physicists, chemists, not only young students, but professional. And Langevin, that is one idea. Another idea is that Langevin at the Collège de France was teaching very, very recent works, the most recent works. That is why I talked about Vin's law, the demonstration of Vin's law, because Langevin was talking every time, was addressing, was showing the most recent works, and that is very special.
So we have another question, Andrew Zauer.
Yes, you mentioned that Langevin wasn't alone in his reticence to publish, that other French mathematicians didn't believe their oral discourse could be turned easily into writing. So where does Poincaré fit into this, who wrote enormously, and in fact constantly revised and republished things over and over? Well, is he a complete counterexample to most of his colleagues who felt that they couldn't convert their oral presentations into writing? He did it all the time.
Poincaré was publishing every time. Yes, his courses. Yes, he had note takers. He is teaching like Borel. Poincaré and Borel had in his teaching note takers. People, young students were writing, okay, but not Langevin. Langevin, he was against the transformation of oral speech in text.
Ariane?
Langevin was writing, he was using blackboard, yes, he was writing, and he was teaching by pen. He had no notes, Langevin. He was writing, and but I don't know, because we don't know. Yeah.
Aaron?
Thank you. I really enjoyed seeing the archival documents. I had a first question, which was that Langevin went to Cambridge, there's the Cavendish.
Yes,
and so there are a few exceptional things about his teaching in the context of France, Paris, right? And one you mentioned was this doing experiments in the classroom, and the other is maybe his interest in the quantum. And I wonder if you see in that the influence of his Cavendish experience. And then the historiographical follow-up is to say, and so is Langevin, because of this international experience, which you just mentioned, really an exception that sort of proves the rule of the early 20th century French non-engagement with the quantum? Or when you say that we should question historians sort of painting the picture of early French physics as not being sufficiently addressed towards the quantum, perhaps, do you think that if we went back and looked at things that, you know, Olivier Derigot or someone I didn't see, that there is a wealth of this activity that just is waiting to be discovered, or is Langevin really just the exception to the historiography that you're invoking?
Yes, okay. My point of view, I'm working on French physics from some years ago, and now I have some ideas. I think that I distinguish between Parisian physicists and the other French physicists. Parisian is a very particular situation. The Parisian people with Langevin were really engaged in new physics. Yes, okay, But even in Paris, we have some people like Betwee. I was really surprised. Because Betwee was doing a very interesting experimental work, you know that. But Betwee at 1912, 1913, 14, was talking about kinetic theory of gases as something that he should to demonstrate. But I'm sorry, from 1900, Marcel Brillouin was talking about kinetic theory. You know, Perrin, Langevin, other people were working on this. So we should be careful on this question, because we have some people that were working in recent work and very new physics, but there was other people that, you know.
So a very quick question from Shaul, and then from Enrique, and then, yeah.
So,
Both very brief.
okay, so I'll do it. I'll try to do it quickly. First, when we talk about the French and quantum, we should remember, of course, the experimental tradition, the one that by Borel, of the wave matter questions, and the Wheaton has written a lot about it, and this is very important. And second, when we talk about courses, it's very different between Maurice and Louise, And when we talk about courses, and if you take notes or not, of course there is very much difference between a textbook course, like a course that is a basic course to students like Poincaré gave, and given a course on recent development in physics, which will be a very different course in 3 years. So that's, I think, also a reason not to write that, not to publish it. What Langevin did here are recent developments in physics courses. These are changing all the time, so there is much more idea of making them oral and not making them, not publishing them. While if you give them the basics of electrodynamics, like Poincaré did, of course you write a book for decades.
Very good. And then a quick question from Enrique.
Just a question. Do you know Ehrenfest's derivation of Wien's law? Because maybe it's the derivation you are looking for. 1911, Ehrenfest has a derivation of Wien's law, and that notebook reminds me about many things. So.
I know that, but my start point is Borel's work, and Borel. And one last thing I'd like to say concerning Langevin is that Langevin was working really in new physics, yes, but his reference, his theory was Lorentz electron theory. It's not Maxwell's, not other thing. It was Lorentz electron theory. And the way for me for understanding this teaching is the thing that Langevin was working on Lorentz electron theory. He was looking to go too far, and he was doing some things. Okay, he was prolongation of the Lorentz electron theory.
Thank you very much. And our next speaker is Anna Schirmacher from the HU Berlin, and this time I'll manage to get away